All right, let's start off here on number 2. So for this one, we're going to set up our kind of key points here. So we're going to go 0, 1, and then 1, base. My base here is 1/3. And then I'll have my horizontal asymptote starting off at y equals 0. I'm going to apply my transformations here. It looks like I have a x plus 1 up there, which means I'm going to subtract 1 from my x's because x lies. And then I got y minus 1 for the minus 1 out back because y tells the truth. So I'm going to subtract 1 from my x's. I'm going to subtract 1 from my y's. So that'll turn into negative 2/3. And then my horizontal asymptote is a y value, so I'm going to subtract 1 there. So I'll draw my horizontal asymptote in there. I got negative 1, 0, and then 0, negative 2/3. So that'll be about there. So I see this is approaching the asymptote as we go right. All right, next up here, number 4. So for this one, once again, start off with my key points. 0, 1, and then 1, base, which our base here is 5, and then our horizontal asymptote at y equals 0. And so my x transformations, I'm going to do x plus 1. My y transformations, I'm going to do 1/2 times y plus 1 for everything outside. So that's kind of for this and for that. So I'm going to add 1 to my x's, and then my y's, I multiply it by 1/2 and then add 1, so this will be 1.5. This one will be 2.5 plus 1, so that's 3.5. And then 1/2 times 0 is still 0, but then I add the 1, so it's y equals 1. So draw my horizontal asymptote right there. 1, 1.5, 2, 3.5, and then there you go. All right, next up here, it says find the amount that the investment will have under the given terms. So it looks like what they're giving me here is P, and then they're asking the question on all of these is what is A. And so if it's compounded monthly, I know N is 12. And so I'll use my formula A equals P times 1 plus R over N to the power of NT. So I'm just going to say A equals 2,500 times 1 plus 0.035 over 12 to the power of parentheses 12 times 4 for time. So from there, I'm just going to type that into the calculator. So 2,500 times 1 plus 0.035 over 12 to the power of parentheses 12 times 4. And that is going to give me 2875. It says 098, so then I'm going to round that to 10. Next up, this one I see is compounded continuously, so that means we use P times e to the RT. And so that's going to be 2,000 times e to the power of 0.03 times 5. And so I'll just type that in the calculator. I do want to use the E button here instead of 2.7 for more accurate calculation. And so that comes out to 2323.67, and that's dollars. All right, next up here it says how much should you invest if you want to end up with the following amount. So how much should you invest is really asking me about P here, so that means the given value is A. So if it's compounded continuously, I'm going to plug that in for A. I don't know P, but we're going to do e to the power of RT. And so I'm just going to divide both sides by e to the 0.05 times 4. And so we can cancel those out. And so P equals 10,000 divided by e to the power of 0.05 times 4. And that comes out to 8187.31. All right, next up here, we're going to find the key points in the horizontal asymptote. And for these, we are going to use 2.7 since it's just kind of for graphing. So we always kind of start off with our same as we did on last page, 0, 1, and 1, base, but we'll use 2.7 for E. And my horizontal asymptote will start at y equals 0. Now my transformations here, I have a negative x up there, so make that a negative x. And then I have a 2 multiplying and a 3 subtracting, so it's going to be 2y minus 3. So my points will be 0 and negative 1 for my x's, since there's no real such thing as negative 0. And then 2y minus 3 is 2 times 1 is 2 minus 3 is negative 1. And then 2.7 times 2 is 5.4 minus 3 is 3.4. Oh, no, it's not. It's 2.4. And then for my horizontal asymptote, it's going to 2 times 0 minus 3 is y equals negative 3. All right, next up here, we want to write this in the form y equals a times b to the x. I would always use this one first. You can plug in x for x and y for y. So 8 equals a times b to the power of 0. Well, this says 8 equals a times 1, and so really a equals 8. If you want to know that, if you want to kind of know that the y-intercept is always a on these, that is true. And so now I'll use my other point to find b. So I know I'm going to say y equals, I know a is 8, and then we'll say times b to the power of x, and then I'll plug in this point for x and y. So we'll say 1/8 equals 8 times b to the power of x. And so then I'm going to divide this side by 8. However, since this side's a fraction, I'm going to multiply it by 1/8 instead. And so I cancel those out, and so I get 1/64 equals, oh, and I forgot to plug in x here. That's actually not -3, it's 3. So we get b to the 3rd power. So now what I can do is I can cube root both sides. And then so b equals, well, the cube root of 1 is, of course, 1. The cube root of 64 is 4, so that means b is 1/4. We'd never do a plus or minus anyway for cube root. That's only for even roots. But even if we did, the base is always positive. So then I got my answer here as y equals 8 times 1/4 to the power of x. All right, the graph is kind of the same idea here. I always find the y-intercept there as 0, 3. And then I want to find another good point that I really know what it is. So I would actually use this one as -1, 6. These other ones over on the other side are all fractions, so I don't really know what they are. So I want to make sure I get a good accurate point there. So I'm going to, once again, I'll just know that this is a. So I'm going to say y equals 3 times b to the x, and then I'll use the other point to find b. So I'm going to plug in 6 right there. I'm going to plug in -1 for b. I'm going to divide both sides by 2. And so b to the -1 equals 2, which to me means that b is 1/2. If you want to show some work here, that would be that 1/b equals 2/1. And then if you cross multiply, 2b equals 1, so b equals 1/2. So I get y equals 3 times 1/2 to the power of x. You can see this is exponential decay, so that actually does make sense.